Hey everyone, JSD Cool here, and welcome to the second devlog for my game, Skinny Man. Now, it came to my attention that some of you, most of you, probably don't know what Skinny Man actually is. So, I will now explain what Skinny Man is. Skinny Man is a platformer game that I have been developing by myself for, like, 4 years now. It's got music, which my friend Tyler made that in the game. You can also find his channel. I don't remember if this channel has it in the channels list, but it might. Find it there. And if he's watching, I'm sure he'll drop a link in the comments. No game engine has actually been used to make this game. Instead, I have made this game in processing, which isn't a game engine in itself, but provides a bunch of graphical related stuff that makes doing graphical things very easily. Basically, it's just an API that wraps a lot of OpenGL stuff and makes it very, very beginner friendly, but I'm taking it to this extreme. Anyhow, in this devlog today, we are going to be doing a bunch of stuff with the multiplayer system in this game, as I've kind of neglected it, and also, it's kind of weird and terrible. So actually, before I actually get into do anything, let's give us a baseline for what the problem is that I'm going to try to solve today. Alright, so first of all, going into multiplayer, here's the multiplayer level selection menu. You can see I have a second player logged in here, which is on a physically separate computer, because that is necessary to show what's going on. I didn't set a name, couldn't be bothered to change the name on either of these devices. That's why we have that going on. So we're just going to select level 5 here and load into it. Alright, so everything seems pretty normal here. Pretty, standard, until I start moving the other player. This is the real time what it looks like on this end when the player's moving. Now, on the other computer, the player looks like they're moving around very smoothly, and in fact, I can move around smoothly as well. Here, you see I'm red, the other one is green. So, what I'm aiming to solve today is this very slow connection issue, or seemingly slow connection, because it doesn't make sense to be this slow. We're not sending that much data. And also, these are on the same LAN with not much going on it right now. And for reference, here's what the ping time is actually currently looking like. Okay, that is actually relatively high, but still doesn't explain how slow that connection was. So the thing I am going to be attempting to change today is how data is encoded and sent over the network between the games. The way we currently do it is we make use of Java's built-in object serialization functionality, which is mostly just implementing this interface here that is just no required methods. Now, what I'm thinking the reason for this being bad is that this is slow. Doing this is a relatively slow operation on either the serialization or deserialization side, plus it will do literally everything in the class, or literally all the class's variables get serialized, regardless of whether or not they actually are relevant, unless you mark them with this special keyword here. So what we're going to do today is we're going to replace this with our own custom system of serializing our class objects into binary data and then converting them back. I have already worked on developing the actual underlying system of input streams, output streams, and functions for doing stuff in a relatively easy way. So I gotta copy those files into Skinny Man now, and yeah, then we can go through the magic of ripping this line out, or ripping this out of everything, and replacing it with my own thing, which will require a lot more work. So time-lapse time! That took a couple of hours to do, which was longer than I, for some reason, thought it would take. I don't know why I didn't think it would take it long, but anyhow, this class is a good example of what I've actually done for most of the classes. So I've added an identifier object here, which is used within the networking stuff to determine which class it is for deserialization purposes. The implementation of the serialization interface had these two methods here added, which this just simply returns this identifier, and this other one is taking the various data stored in this class and adding it to the output of the actual byte data via this serialized data class. And then the other thing I did for all these classes was add a new constructor that takes this parameter here. That way, in a moment, we'll be able to actually add all these classes with their specific constructors to a specific collection that'll be able to be used at runtime to determine which classes to construct out of the incoming bytes from the input stream. So now what we should do is we should make sure we can run it, which I for some reason cannot, because I get this random exception in initialization error. It wants to highlight this line as well, which is kind of random because I don't think that's doing anything. That constructor works just fine, and this actual line was there before, so I'm gonna have to do a little bit deeper digging to figure out what this error actually means. Okay, so I've figured out what this error is referring to. The real issue here is that processing isn't showing me the full stack trace of what's causing it, instead it's just giving me this nebulous error. But the issue is that in selected level info here, so let's find that. I'm declaring this identifier here. Obviously it's static, so when the class is initialized is when it's actually going to execute this constructor here. But I did not do this as valid. You see, one of the things with identifiers is I did not allow spaces to be a valid character. And it's programmed to throw an exception if you try to create an identifier that has an invalid, or that has invalid characters in it. And obviously what you're supposed to have there is then you're supposed to be able to see the stack traces, and the actual exception that it throws says, okay, this can only contain these characters and this is where you've done it. But because processing's being weird, it'll just be like, well, here's the overall thing, and you don't need the stack trace, obviously, because you can figure out based off where we highlight what is wrong. So now it should just work. Yes, it's working. It showed up on the wrong monitor. Alright then, swapping out these IO streams for the ones that I made was actually pretty painless. Just change what the object type is, change their constructors here, and then I had to change the names of the methods used to read and write to them, as they are slightly different. But besides that, everything multiplayer code-wise should just all work together. So let's test this. I got my other computer here with the game booted up. Same changes and all, so... Well, that doesn't bode well. Oh, it crashed. And we got a stack trace here. Wait, is that... Okay, it did disconnect. Read timeout. Huh, I have no idea what that means. Okay, well, this just means that it didn't read anything in time for whatever the timeout was. But yeah, I'm stupid. I forgot to actually do the thing that I have to do so that it knows which classes to use the constructors of. I haven't done that yet, and that's kind of necessary for the things to actually be able to properly communicate back and forth. Alright, so specifically, this is what I had to do here. I had to call this static method on the serial registry class with the identifier from each of these classes and this reference to that specific constructor we made on each of these classes. There are like 64 of these here. Honestly, it wasn't that bad. I just went to the command prompt, copied the names of all the files, got rid of all the files that weren't relevant, and then just added all the other stuff around them. And hopefully, it all works now. So here is attempt number 2, trying to connect with the client. Well, that's fun. Null pointer exception. We love when we have null. Okay, I found what the issue was. So in this class here, the selected level info, I was apparently shortcutting not actually sending data for these 3 options here, by instead just sending in null. And my serialization system doesn't like nulls, because, it calls methods on stuff. So I had to do a little bit of a thing right here so that if it sends a null, to instead send in a blank string, and that so far appears to be doing the trick. let's see what happens when we run a level now. Disconnected immediately. Love to see it. Okay, this issue was another issue of a string being sent as null because laziness. So instead of trying to figure out every other place in the code I did that, I've just added this here to the section where strings are added to the serialized thing to say just, hey, if the string happens to be null, then just substitute an empty string for it. Much more intelligent, will probably save me a lot of headaching in the future. Okay, let's see what issue pops up next. Okay, it's there. Let's see. Okay, that's not really better performance than before necessarily. To be fair, I am right now thinking that a fair bit of this is actually based off of Wi-Fi being a thing. And the Wi-Fi is therefore a bit a bit high in terms of ping, and I don't have any like entity interpolation going on. But overall, actually, this does seem to be, at least from before, does seem to be at least a little bit more regular in how often it's going, and I think it's more things. So actually here, I'll connect my laptop to Ethernet and see if that makes the connection better. Alright then, with a directly wired connection, this is miles better, as you can see. Obviously, Wi-Fi was doing a lot of the latency there, but yeah, you can actually kind of tell what's going on, and I think this, at least in my opinion, this feels like it's better than going over Ethernet previously, as previously I remember, even if it was a hardwired connection like this, it still wasn't this fluid. It was still way choppier. So yeah, this is actually so far a great success. But of course, so far I've just been testing, you know, the level itself. And actually, let's go complete this level quickly. Okay, completed the level. Nothing weird happened there. It looks like all the data is successfully being transferred between the two, and we only have, oh, we have 7 minutes up. But okay, so now we have more things to test though, because keep in mind that was a built-in level. In built-in levels, the amount of the classes that we actually just utilized there was actually relatively low, because just relatively low. Most of the classes are control signal classes, but only the control signal classes were in use. None of the actual level data was in use transferring between them, because that only happens when you're doing custom levels, and for some reason, I don't think any of these are actually going to be compatible. Maybe one of my test levels is. Level's incompatible. That's so... Here. Oh, right. My multiplayer menu. It's horrible. It was kind of supposed to be built to scale with your UI, and the main parts do, but the buttons do not, which makes it bad. Anyhow, I can select here. Oh, cool. This one. This one is set as... compatible with this version. That's a few versions of though when I made this level though. Okay. Okay, I guess I'll test this and see if both players get it just fine. So waiting for clients. It's downloading, right? Because there's some stuff there's some assets that has to shit. It didn't work. The client crashed this time, which actually it might be a null pointer exception. Well, no, the client fully crashed this time, not just like got an exception and disconnected. Okay, so apparently what happened there is I forgot to actually register the logic board. It's kind of embarrassing, but anyhow. Attempt number 11D7, and it disconnected immediately again. Okay, what does it say? Cannot read field stages because interdimensional portal.source.level is null. Okay, so this bug actually didn't really have anything to do with my networking code basically at all. Rather, instead, it has to do with how I actually get the level onto the other computers. So while we may have all these classes that are responsible for sending the level over, I do generally require that the level be saved directly locally to the disk, and then from there loaded once again, because there's some minute stuff that can't be transferred over the network, like references to the level itself. And then there's some other functional stuff that needs to actually be properly loaded instead of just deserialized from being over the network. So the issue with that is that in the interdimensional portal class here, within the save function, which is of course responsible for helping write it to the disk, I reference the global level object, which in the ordinary course of gameplay or level editing is where the current level that you're working on or playing is stored. But in this case, when you're downloading a level in multiplayer, this does not point to the same level. And so the actual issue was that my laptop hadn't previously loaded a level, so the global level object was null, and therefore couldn't do this on that. But this, even if I had loaded a level, this would have two potential bad results. One, if the stage referred to is, in fact, not 3D here, then it wouldn't save the correct values, or it might not save the link Z, which I think I may have had issues with before. Or the other thing is, if the link index is just simply doesn't exist on the level that you were playing before, had less levels or whatever, then you'll just crash from a null pointer exception. So fixing this was actually quite important, and in fact, fixing this was basically as simple as setting the global level object to be this level, then resetting that back to null after the level has been saved. Alright then, well, let's see if this did in fact work, or what the next bug that I'm going to have here is. Okay, it's actually downloading. Okay, that downloaded. And it loaded. Everything's looking completely good here. Just go to that portal there. Okay, I think this is successful. I'm gonna see what I'm doing next, because I feel like this isn't the end of the episode. Okay, so for what I'm actually thinking of doing next is I think I want to potentially add the option to have this little list of various debug information right here also show the ping to the client. I'm not sure if I necessarily have to be implementing that myself, or if the socket itself will have a method to actually be calculating the ping, which would actually be really nice if it did. But actually, because as you can see right now, it's actually, well, okay. As I'm saying this, it does go a little bit down the tube, but look, it's actually going pretty fast right now. Whee! This is pretty playable remotely, honestly. Obviously, Wi-Fi does a lot of badness in there, but I do think my system is overall a bit faster than the old system of just having Java handle it. Alright, so that actually didn't take too much effort to implement. So here you can see it actually might be a little bit difficult because it's small text here. I'll screw up my UI to make it a bit bigger. Here you can see I've added to the little bit list of debug stuff here what the current ping is. Well, at least for when there are two clients, that's the current ping. If there's more than two clients and you're on the host like this, the ping will be just an average of all the clients' pings. But on the client side, or if there's only one connected client, which is what happens when you're on the client side of things, it will just register the current ping. So it looks like we're hovering around 100 milliseconds right now, which isn't too bad. I obviously do not know how much of that is the actual process of serializing and deserializing the objects, and how much of that is just the network being weird and TCP overhead. Oh, look, it's spiking there. That happens from time to time. But obviously we're just sitting on the main menu, nothing's actually happening. So let's get into a level and see what it's like then. Okay, I guess it stands to a bit reason that screen's a bit broken right now. But okay, ping is not substantially different right now within the actual context of running multiplayer. It's a little bit worse than it was earlier, but that's again network conditions, I'm almost certain. But yeah, so that's, I guess, another little cool feature there. I guess the only other thing we really got to test is with a co-op level, so let's go do that. We'll do this and then we'll test the custom levels. Oh, hello. Okay. Again, this may just be completely coincidental, but that's a significantly lower ping. Again, I'm relatively certain this is just coincidental. But yeah, that's 40 milliseconds. That's more than 20 back and forths per second. Oh right, you gotta stand on the button here. I'm not even standing on the button. Look at that. There we go. Yeah, this is, I guess, an ideal connection here. Let's go see what the custom levels are, right? Okay, no, actually, it is definitely weird. I actually thought co-op levels would be legitimately slower than not. Like, why is... What? I mean, good, because co-op requires more or less, more whatever network connection. Weird, though. Why is it like... Why is the co-op level, like, take half the ping time that a non-co-op level does? Okay, I'm gonna have to deep dive into this and figure that out. But, I just want to see that with UGC levels, when I'm downloading the level, what's the ping like? And then click play. Okay, so it varies widely, although it was a little high at first when I guess it sent the entire level, but now that it's just sending the individual bits of the level, it is relatively low. Lower than it generally is in the menu as well. I don't know why the ping is so high in the menu and in a normal level, but in like co-op levels it's so much lower. Like, this is a co-op level, or at least that's the way it's billed right now. So I guess my deserialization does actually take a fair amount of time, potentially. I'm gonna look into this a bit. Okay, so I kind of figured out what's causing the ping time to literally double when you're in a non-co-op level, so I guess the PvP levels. That is specifically apparently this line here on the client's side of the processing here, which is when we're in multiplayer mode 1, which is the non-co-op mode, add the current best score information. This is what is sent to the server so that it can figure out what the leaderboard is going to be like here. Now, I guess it's not necessarily necessary to send the name, because the server could piece that together from what name is on the client. So maybe I'll remove that, but then it also has the time, actually. So here, let's go to this class and see what it's like currently now. This class is so fucking simple. It cannot possibly be the serialization or deserialization of this. Yes, that is a string that's being serialized as deserialized, and maybe not sending the client's name every time would actually be better, because strings might be one of the slowest things in this process. That's something I can, I guess, test out later, now that I have a lot more granular control over all this. But the thing I gotta look at now is what in terms of processing this input information is actually potentially making this lag so much. Okay, looks like I was wrong, because it's just, with no modification, working at 40 milliseconds ping right now. So I don't know what's going on, before or now. I'm pretty sure that, hang on a second. Yeah, no idea what's going on or what could be causing that. Anyway, with that, I think I'm going to call this devlog there. It's been ultimately very successful. The serialization system mostly worked first time, and I think it improved performance overall, so that's great. Just a reminder that this is of course a development build of the game that is not yet available publicly as a release. I guess the source code is on GitHub though, but if you did want to check out the currently released version of this game, which does not have this feature in it, but does have a bunch of other stuff, then please feel free to do so at the link in the description below. With that being said, thank you so much for watching. I'll leave a like on the video if you enjoyed. Leave a comment if you have anything you want to add to the conversation. You know, subscribe if you want to do that, and I'll see you next time. Bye!